Hello friends, today in this session we will discuss failure in rigid payments. Rigid payments like flexible payments suffer from both major and minor distresses, and these distresses are broadly classified into two categories. One is functional distresses, another is structural distresses. This part of functional distresses we have covered in our earlier session. Today in this session we will discuss various types of structural distresses, their causes and possible repair. There are four main causes of structural distresses in a concrete pavement. The first is deficiency of pavement material. The various defects of rigid pavements are due to poor workmanship, use of soft aggregates, poor surface finish, improper curing, poor quality of joint filler, and many more such deficiency in the materials. Second is structural inadequacy. If the pavement system is structurally unstable, such as inadequate pavement thickness, inadequate subgrade support, poor subgrade soil, incorrect spacing of joints, the rigid pavements develop various forms of structural failure. In addition to this, the climatic conditions and heavy wheel load are also sometimes responsible for structural failure of a rigid pavement. There can be several types of structural failure, and we will discuss in this spalling of joints, sealant failure and or loss of sealant material, mud pumping, plastic shrinkage cracks, corner cracks, diagonal cracks, longitudinal cracks, warping cracks, edge and crowfoot or Y-shaped crack, transverse crack, durability crack, punch outs and deep foundation movement. The first is spalling of joints or cracks. Spalling is the deterioration of a concrete surface over time. Initially, cracks are formed and then pieces of the concrete fall off the pavement at joints, cracks and edges. Various causes of spalling are ingress of stones and other incompressible materials into joint, dynamic traffic loads at slab ends, mechanical damage of the joints, weak concrete, poorly compacted or non-durable concrete, particularly at construction joints, failure or defects of double bar transfer system, joints intersections, or slab overstressing due to heavy traffic. Main cause of spalling is poor performance of joints. And for repair of spalling of joints, clean the area, dispose of debris of the right of way, saw at least 40 mm deep around repair area and make faces vertical around the perimeter of the repair area, provide a uniform rough surface free of loose particles and suitable for bonding, remove concrete to a depth of 40 mm or the depth of deteriorated concrete, whichever is greater, using chipping hammers, mix and place the rapid set concrete and cure in accordance with manufacturer's recommendations. Screed concrete to conform to roadway surface and provide a rough broom finish. Sealant failure or loss of sealing material. Joint sealant damage is any joint seal condition that will allow accumulation of incompressible materials in the joints or allow significant infiltration of water. If not taken care of in time, it can result in buckling, shattering or spalling of the slab. Typical types of joint seal damage are stripping of joint sealant, exclusion of joint sealant, weed growth, hardening of the filler due to oxidation, loss of bond to the slab edges, and lack or absence of sealant in the joint. The failure of the sealant itself is not catastrophic, but this failure can lead to a great reduction of the service life of the surrounding pavement section. The damaged joint sealer should preferably be replaced before the start of the monsoon. The expansion and contraction joints are opened up, and after cleaning with brush, they are filled with the suitable material, preferably by a rubber-based asphalt sealer. With passage of time, the joint filler material may get damaged or deteriorated. In such cases, the entire joint is carefully newly constructed by removing the filler and sealer materials and then filling up with new material. The opening of the joint is the widest in winter season, and therefore the replacement of a joint should preferably be done during winter season only. Next is mud pumping. The water inflates through the joints, cracks and edges of the rigid pavement and forms the soil slurry known as mud. When heavy load passes over the pavement, the mud is ejected out through the joints and cracks of the pavement, and that is called the mud pumping. Due to repeated occurrence of mud pumping, there is considerable loss of fine-grained soil from the subgrade, and it results in lack of support at these points. The continued traffic movement further develops the cracking of pavement, and therefore the failure of rigid pavement due to mud pumping is generally of a progressive nature. The reason for mud pumping is moisture between subgrade and base course material, or heavy loads, or lack of subgrade support. A good base course can prevent mud pumping. Pumping can be avoided by the prevention of water accumulation at the pavement base interface. And this can be achieved by reducing the deflection to a minimum value and by the provision of a strong, well-constructed base. The remedial measures for mud pumping are sealing of the crack with bitumen or cement, full depth repair of the cracked slab, and double bars can also be provided to increase the load transfer across any significant joint created by patch repair. The mud jacking. Mud jacking is the process of pumping cement slurry under the slab through the holes to lift it back to its original height. Plastic shrinkage cracks. These cracks are caused by the rapid loss of water from the surface of the fresh concrete. The cracks form when the rate of evaporation is greater than the concrete's bleeding rate. These cracks are formed when concrete is still in plastic state, and that is why they are called plastic cracks. Plastic shrinkage cracking occurs when construction takes place in hot weather. The climatic conditions that are suitable for their formation are high concrete temperature, low ambient relative humidity, high wind velocity. The concrete properties are also responsible for shrinkage cracks, like type and content of Portland cement and supplementary cementitious materials, water cementitious material ratio, and type and dosage rate of chemical admixtures and temperature of the fresh concrete. Even the construction operations, including screeding and finishing operations, may influence the risk of plastic shrinkage cracks. If the concrete is in plastic state, then plastic shrinkage cracks can be repaired by reworking the concrete surface using a surface vibrator and closing the cracks to their full depth and then completing the surface finishing. But if the concrete has hardened, then the cracks may be either dormant or active. The dormant cracks do not move with time, or they do not open with time. Fine hairline cracks may not need any repair, but many times these cracks become durability problem in future, and therefore it is always good to seal them by using some protective coating. Wider dormant cracks may be sealed by epoxy or polyurethane or acrylic resins followed by a protective coating or membrane. Active cracks are those which grow with time, and the reasons for their growth may be either continuous foundation settlement, or sometimes the cracks start acting as contraction and expansion joint and open with time. These cracks should be treated as if they are moving joints, and the repair should cater for the anticipated potential movement of these cracks. V-cutting along the line of the crack and then sealing it with appropriate sealant material will protect against further expansion of the crack and possible water ingress. Next is corner crack. Corner cracks may occur either at the edge of the slab or where the transverse joint intersects the longitudinal joint. And if not repaired in time, they work themselves free and sink. at the edge of the pavement, they may move horizontally as well. Now, it is a distinct full depth fracture in a jointed concrete pavement. Corner cracks intersect adjacent transverse and longitudinal joints at an angle approximately 45 degrees in the direction of traffic. Now, these cracks intersect the joints at a distance less than or equal to 1/2 of the slab length on both sides, measured from the corner of the slab. For example, if the slab dimension is 4 meter by 4 meter, that has a crack intersecting the joint 1.5 meter from the corner on one side and 3 meter on other side, that is not a corner break or corner crack. It is diagonal crack. But if the crack that intersects 1.2 meter on one side and 1.5 meter on other side is considered as corner crack. So the necessary condition is that this length should be less than half of the slab length. A corner break differs from a corner spall in that the corner extends vertically through the entire slab thickness, whereas a corner spall intersects the joint at an angle. Load repetition combined with loss of support and curling stresses usually cause the corner breaks. Corner cracks are caused by lack of support due to pumping or loss of load transfer at the joint, or it may be because of poor load transfer devices. Load repetition combined with loss of support and curling stresses usually causes cracks at the slab core. The repair is either full slab replacement or the repair for the full depth of the affected portion. Diagonal and transverse cracks. These cracks are oriented obliquely across a slab at roughly 30 to 60 degree angle from the pavement center line. These cracks are different from transverse cracks. Transverse cracks, they are also called mid-panel or mid-slab cracking, is oriented laterally across the pavement and perpendicular to the pavement center line. This is a transverse crack and this is a diagonal crack. These cracks typically extend through the entire thickness of the slab and can also develop in conjunction with one another to produce what is often referred to as a shattered or broken slab. A shattered slab is a PCC slab that is divided into 4 or more than 4 pieces by intersecting cracks. Shattered slabs are typically the result of overloading, inadequate support, or both. If all pieces or cracks are contained within a corner break, the distress is not categorized as a shattered slab, rather it is a severe corner break. Factors which contribute to the diagonal cracks are environmental conditions like temperature, humidity, joint lockup, or improper joint spacing, inadequate slab thickness, poor mix design, generalized traffic, or loss of support to the slab. Full depth repair and slab replacement are commonly used to address deteriorated transverse and diagonal cracks in concrete pavements. Double bars retrofit of diagonal cracks is an alternative to full depth repair or slab replacement. In this process, double bars are installed in slots across the crack, and it helps in providing good load transfer across the crack and reducing deflections, pumping, and further crack propagation. Next is longitudinal cracks. These cracks are parallel to traffic movement, and such cracks are generally straight, but in some cases may be curved also. When the tensile stress induced either by traffic or environmental conditions or both exceeds the tensile strength of the concrete, a concrete slab would crack in transverse, longitudinal, or corner cracking types. High level of friction or bond between the concrete slab and the underlying base can restrain the contraction and shrinkage of the slab and that could be main reason for developing longitudinal crack in the slab. They can also develop due to late sawing or inadequate saw cut depth. These cracks can be caused by localized movements, settlement, frost heave, or swelling of the base or the natural subgrade. Low severity cracks can be sealed with epoxy material to prevent entry of moisture into the subgrade through the cracks and further raveling of the cracked edges. In case of high severity cracks, full depth repair and slab replacement are normally recommended. Cross stitching and slot stitching are alternative to full depth repair or slab replacement. Here, deformed tie bars are installed either in holes that are drilled at angle through the cracks from both sides or in slots across the crack as shown here. These bars help to hold the cracks tight and maintain good load transfer across the crack. Warping cracks. When joints are not designed properly, it prevents expansion of concrete slab and therefore results in development of excessive stresses. This stress causes formation of warping cracks of the concrete slab near the joint edge. Warping or curling is not visible, but it is measurable. This type of crack can be prevented by providing proper reinforcement in the long and transverse joints. Hinge joints are generally used to relieve the stress due to warping. The next is edge cracking. These are the cracks parallel to pavement edge or at some angle. And the most common cause for this type of crack is poor drainage conditions, lack of support at the pavement edge. As a result, underlying base materials settle and become weaker. Heavy vegetation along the pavement edge and heavy traffic can also be the reason for edge cracking. The most prominent reasons for edge cracking are failure of expansion joint filler to expand, infiltration of foreign materials into the joint, overloading of the pavement, thermal expansion and contraction, moisture stresses, slab curling, and loss of support underneath the slab. Change the joint filler material. If it is because of failure of expansion joint filler, then it is better to change the joint filler material and improve the joint. But these cracks, if they are not the problem of the joints, then these should be fixed. And for fixing, the first step in correcting the problem is to remove any existing vegetation across the edge of the pavement and fix any drainage problem. Then crack seal or fill the cracks to prevent further deterioration, or remove and reconstruct to full depth, fixing any support issue. Next is transverse crack. Transverse cracks are single cracks perpendicular to the pavement center line. And reasons for these cracks may be many. Tensile stresses developed in concrete are more than tensile strength of the concrete. Excessive drying shrinkage stresses, inadequate depth, and or late initial joint groove sawing, excessive joint spacing, misaligned or corroded double bars, delay or interruption of concrete placing for more than 30 minutes, excessive overloading, excessive sub-base restraint, settlement, or poor sub-base support at localized area. Low severity cracks are usually warping or friction related and are not considered major structural distresses. But medium or high severity cracks are usually working cracks and are considered major structural distresses. The maintenance of options which are available: if the transverse cracks are inactive and no secondary distresses have occurred, the cracks can be left unrepaired or sealed if they are wide enough. If the transverse cracks are active due to either swelling soils or loss of foundation support, then base materials must be treated with full depth repair.
Next is decracking. Decracking is also called durability cracking in the pavement. It is defined by hairline cracks occurring in a limited area of the slab, such as one or two corners or along one joint, with little or no disintegration in the slab. Durability cracking is caused by concrete inability to withstand environmental factors such as freeze-thaw cycles. It usually appears as a pattern of cracks running parallel to a joint or linear crack. And this type of cracking may eventually lead to disintegration of the concrete within 1 to 2 feet of the joint or the crack. Decracking is an indicative of a general aggregate freeze-thaw problem. Although a full depth patch or partial depth patch can repair the affected area, it does not address the root problem and will not, of course, prevent decracking happening elsewhere. The prevention of decracking in the slab lies in selection of aggregates that are known to perform well in freeze and thaw cycles. If marginal aggregates are to be used, reducing the maximum aggregate particle size can help reduce the problem. Providing an effective drainage system to move free water out from under the pavement may also be helpful. Next is punch outs. The area enclosed by two closely spaced transverse cracks, a short longitudinal crack, and the edge of the pavement or a longitudinal crack, that is the area formed in case of a punch out. More common with continuously reinforced concrete pavements. The problem with the punch out is the roughness, that riding quality is affected. It allows moisture infiltration leading to erosion of the base or sub-base support, and cracks will spall and disintegrate. A punch out can indicate a localized construction defect such as inadequate consolidation. In CRCP, it can be caused by steel corrosion, inadequate amount of steel, or excessively wide shrinkage cracks. And full depth repair or full depth patch is the only repair technique for punch outs in a concrete slab. And the last one is deep foundation movement. And it is characterized by gentle slopes and relatively great length of defected area. So it is basically changing the or disturbance in the cross slope of the pavement. It is mainly due to consolidation and shear failure of deep soil strata. The slab generally follows the contour of the foundation, and in extreme conditions, the maximum amount of settlement can be as high as 50 to 60 centimeters. And the only solution to this problem is to repair the soil subgrade. So friends, thank you very much for watching this video. You can write your comments in the comment box.